906 words within range. Here's the script. The salt-hoarding reason your own blood would burn apart inside Mono Lake is the same secret the lake is now hiding in plain sight. And in July of 2023, the water outside Los Angeles turned the color of raw blood, and not one scientist can tell you why it happened. Your blood is salty, not California desert salty. Just enough salt to keep your cells alive, tuned by millions of years of evolution to a razor-thin balance. Push that balance 3 times higher and your red blood cells shrivel. Push it the other way and they explode. Mono Lake sits at nearly 3 times the salinity of the ocean and 2.5 times more alkaline than your bloodstream can survive. That number isn't decoration. It's the reason nothing should be alive in there at all. And yet something is. Trillions of somethings. And this summer they turned the whole lake pink. Mono Lake has existed for over 1 million years. One of the oldest lakes in North America, sitting in a bowl of desert east of Yosemite with no rivers flowing out, only in. Every mineral, every salt, every trace of alkaline rock that has ever washed into it has stayed there, concentrating year after year with nowhere else to go. Which means the lake has spent 1 million years hoarding chemistry the way your body hoards nothing, ever, because your body would die trying. The organisms that live inside Mono Lake, brine shrimp by the trillion, alkali flies coating the shoreline in a living carpet, survive by doing something your own cells physically cannot. They pump salt back out of themselves, constantly, just to stay 1 step ahead of the water trying to kill them. Now picture that same water holding its breath for 1 million years, suddenly changing color overnight. That's what happened. Satellite images and shoreline photos in 2023 showed sections of Mono Lake shifting from its usual pale blue-green to a deep, unmistakable pink, almost the shade of diluted blood. Researchers pointed to a microscopic organism, a salt-loving algae related to the same species that turns other hypersaline lakes crimson around the world, from Australia to Senegal. Under brutal sun and extreme salt stress, this algae produces a red pigment as a kind of internal sunscreen, protecting itself from radiation that would otherwise cook it alive. In theory, that explains the color. In practice, it explains almost nothing about why Mono Lake, specifically, chose this year to bloom like that. Because here's the pattern interrupt nobody saw coming. Mono Lake had a documented pink phase decades ago too, and then it stopped, and the exact salinity threshold that supposedly triggers the algae never fully returned. The lake's salt levels have been dropping since court-ordered water restoration began sending more freshwater back into it, undoing decades of diversion by Los Angeles that once nearly killed the lake completely. Lower salinity should make conditions worse for a salt-loving organism, not better. Yet the pink came back anyway, stronger and more widespread than researchers expected, right as the lake was supposed to be healing. So remember that number from the beginning, nearly 3 times ocean salinity, the concentration your own blood cannot survive. That number has been quietly falling for years now, the direct result of a decades-long legal fight to save Mono Lake from the aqueducts that once drained it toward Los Angeles faucets. Falling salinity was supposed to mean a safer lake, more life, more balance. Instead, in 2023, it coincided with a bloom so intense it stained the water for miles, visible from orbit. Some researchers suspect a rare combination of warmer surface temperatures, shifting wind patterns, and a sudden nutrient pulse from runoff created a narrow window where the algae exploded before the changing chemistry could stop it. Others aren't convinced temperature explains a shift this dramatic. Water samples taken during the bloom showed pigment concentrations far beyond what lab models predict for that salinity range, which means the lake did something the equations say it shouldn't have been able to do. Nobody has been able to reproduce the exact trigger since. Teams have tried recreating the same salinity, the same temperature curve, the same nutrient load in controlled samples, and the bloom simply refuses to happen on command. It only happened once in the open lake, under conditions nobody fully logged in time. It simply occurred, was documented after the fact, and then began to fade, leaving behind a single summer of blood-colored water, a stack of photographs, and no confirmed cause anyone is willing to publish with confidence. If a lake can hoard 1 million years of salt, hide a trigger no model predicted, and then quietly let the color drain back out before anyone could isolate what caused it, that means the chemistry underneath Mono Lake is still shifting in ways nobody is currently tracking in real time. The same restoration effort meant to save the lake may be pushing it toward a threshold scientists haven't mapped yet. And hypersaline lakes around the world, from Utah to Australia, have shown the same unexplained color swings in years when their salt balance changed fastest, which raises the harder question researchers won't say out loud yet. What happens the next time Mono Lake's salinity crosses that same invisible line? And will anyone even be watching when it turns again?